Alright, we're looking at 3C now. I have 3 reactants this time. So to find my limiting reagent, I'm going to possibly do as many as 3 calculations. Alright, so I'm going to get my equation balanced real quick. So I have 2 sodiums there and 3 here. So I'm going to put a 3 in front of this and a 2 in front of that to give myself 6 sodiums on both sides. Alright. Now, my next species I'm going to take care of, I normally ignore something like BO3 because it's part of a polyatomic ion, but I don't have BO3 over here, so I'm going to do the borons separately. So I have 3 times 4 borons, so 12 borons, so I'm going to put a 12 in front of that. Alright, I'm actually going to skip the O's because they're found all over the place. I'm going to go now to my HPO4, and because of the PO4s and all the phosphates are right there, this must be a 2. Alright, I'm going to be able to do the rest just by looking at the hydrogens. So I have 6 hydrogens right now here, and on my product side I have 12 times 3, so I have 36 hydrogens. And since that's my only source of hydrogens, I need this to represent 30 of them, so I'm going to put a 15 there. And if we check our oxygens, which is a pain in the butt, but I got 3 and 7, 3 times 7, so 21 oxygens there. I have 2 times 4, 8 oxygens, and then I have 15. So on the reactant side, I have a grand total of 44 oxygens. On the product side, I have a 12 times 3, 36, and then I have 2 times 4, 8. So I do get all the oxygens accounted for. Alright, how I'm going to do the next part is I'm going to first decide which is limiting between the sodium with the boron in there and the H3PO4. And how I'm going to do that is I'm just going to assume I have 10 grams of Na2B4O7 because it's the first thing listed. And 1 mole of that is 201.21 grams. And what I'm going to compare it to now is that second species, the phosphoric acid. So 3 of these sodium boron molecules. And molecular weight, 1 mole of H3PO4. I get 97.99 grams. So let's find out now how many grams of H3PO4 we would need to use up all 10 grams of the sodium and boron. So 10 divided by 201.21 times 2 divided by 3 times 97.99. I get 3. And I am noticing I don't like how that looked. So fix the grams there, fix these parentheses a little. And this would be, I would need 3.25 grams of H3PO4. Alright, now technically up here I have 10 grams, or at least that's what it says we're starting with. So because of that, I know between those two, this is in excess. Now I can't put limiting on this, on the sodium boron yet, because I need to compare it to water now. So that's what I'm going to do. I'm going to do the same 10 grams of the sodium borate, convert that into moles, have a 3 down here because it's the same stoichiometric ratio value there, but on top, since now I care about the water, I'm going to put the 15 waters up here. And then the molecular weight of water. And 18.016 grams. So I have 10 divided by 201.21 times 15 divided by 3 times 18.016, and I get that that would need 4.48 grams of water. Alright, the nice thing is that just shows us both of these are limiting, because both of those values are less than 10, so the sodium boron complex molecule is my limiting reagent. Now that I have all this written out, I want you guys to notice something here. When I started with that 10, my mass and the coefficient for the sodium borohydride, these two guys, are on the bottom. The 15 and the molecular weight, so both the things for the water, are on the top. Now, that same thing happened here. See how we got the 2 and the 97? They match. And the 3 and the 201 are on the bottom. Alright, so why I'm pointing that out now, I want you to realize that you can typically figure out the limiting reagent quite quick when you get this balanced and when you get the molecular weights here, because what I can recommend you do, if you just take that 3 times the 201, doesn't have to be the full number, and then the 2 times the 97, well, that'd be 98, wouldn't it? And then 15 times 18. You get 3 numbers by taking those 3 products. Turns out that the biggest one there is typically going to relate to your limiting reagent, especially if you start with the same amounts with all 3 of them. Since all of these were 10 grams, that one big one is going to be used up much, much faster, is what that translates to. So I could have predicted that was the limiting reagent just by doing something along those lines. Alright, but now that I have these 2 values, my remaining amount of H3PO4 is going to be 10 minus that 3.25. Just give me 6.75 grams of H3PO4 remaining. And because 10 minus 4.48 is going to be 5.52 grams of water remaining. So I have this limiting and I have my remaining amounts.